Hi, welcome to this lesson on trigonometry, double angles. Let's have a look at question 3. We want to prove the following identity. 1 over sine 2a minus 1 over tan 2a is equal to tan a. So I'm going to start with the left-hand side as that is the considerably more difficult side. So let's try and simplify it and see if we can get tan a. So let's rewrite it out. Now, I have 1 over sine 2a minus. Now, tan of an angle, we know by the quotient identity, is sine of that angle divided by cos of that angle. So it's sine 2a over cos 2a. But when you divide by a fraction, you are multiplying by the reciprocal. So it's minus 1 times now cos 2a over sine 2a. Alright, so now I'm going to have 1 over sine 2a minus cos 2a over sine 2a. Now you can see these two fractions have the same denominator, sine 2a. So I can do the subtraction in the numerator. So sine 2a is the denominator. And I have 1 minus cos 2a. At this point, we've got to ask ourselves, well, what are the double angle identities that we know? Well, we know that sine of 2 times an angle is 2 times sine the angle, cos the angle. And then cos 2 times the angle, that's going to be one of 3 options, right? It's cos squared a minus sine squared a, or it's 2 cos squared a minus 1, or 1 minus 2 sine squared a. Okay, so this is equal to 1 minus, so we can choose any one of the 3, but I feel like because sine 2a, when we simplify it in the denominator, we're just going to have 2 sine a cos a, that we should maybe avoid using the square expression for cos 2a. So I'm going to go ahead and use this one here, 2 cos squared a minus 1, and see what happens. So 2 cos squared a minus 1. Okay, so if I distribute out the negative sign, I get 1 minus 2 cos squared a minus 1 is plus 1, all over 2 sine a cos a. Okay, now we're going to have 1 plus 1 is 2 minus 2 cos squared a, all over 2 sine a cos a. We're getting there. Now I can pull out a common factor of 2 in the numerator here. So I get 2 times 1 minus cos squared a. So eventually it would have probably been better to use the third one here because we're going to get exactly a sine squared term coming out. So I get 2 sine a cos a. And then 1 minus cos squared a, that's a trig identity. That's 2 times sine squared a. Okay, which you would have got if you used this third one as well. Times 2, or divided by 2 times sine a cos a. Okay, so the 2's will divide. Sine squared divided by sine a, right? So one of those will divide out. So you're left with sine a in the numerator divided by cos a in the denominator. But that is tan a, which is the right-hand side. So we've mathematically proven that the left-hand side is indeed equal to the right-hand side. So what did we have to do here? We needed our algebraic toolkit because we needed to know how to subtract fractions with common denominators. We needed our trigonometric toolkit, that being the double angle formulae for sine of 2a and cos of 2a. Putting that together, we did our algebraic gymnastics and solved for that given expression. Okay, so we proved that the left-hand side is equal to the right-hand side essentially. All right, that's how we would do this type of question. I'll see you in the next one.